Hello everybody, my name is Alessandro Roncone and I'm a new assistant professor in the computer science department here at CU Boulder, and I am one of the most recent hires in the autonomous systems research that Eric was talking about earlier. And my research is about developing algorithms and systems for humans and robots to work together, and in particular for robots to help people in a manufacturing environment. This field is usually referred to as a human-robot collaboration, and it is not anymore about lowering the costs of automation, of production through automation, but it's mainly about changing the nature of how manufacturing works. We aim at developing the new generation of robot workers, collaborators, and companions that will allow for humans to be more productive, for salaries to rise, and for new jobs to be created. And to reach this goal, I approach the problem from two different perspectives. First one is the low-level perspective of the physical human-robot interaction. So how to develop algorithms for robots to physically interact with the environment and people. And in this area, I have worked on distributed robot controllers that exploit a local distributed information around the body to leverage, that's fine, this is the one in the left, to perform better action around the environment. I'm strongly supportive of the fact that a key enabling technology for robots to better interact with people is the development of artificial tactile sensing, so artificial skins. And in this regard, we are kind of pushing this idea further thanks to a recent seed grant from the Research and Innovation Office. It's an interdisciplinary project that pushes this idea further to the soft robotics domain. And so we're going to be working with a professor from mechanical engineering, Jialiang Xiao, a professor from electrical engineering, Emiliano Dallanese, and myself to move from material sciences to distributed controllers to robotics. And this is one of the most exciting things that happened like yesterday. So I'm super excited about it. And on the other side, the other angle of approach is to attack the problem from the high-level perspective of social interactions. So how to develop algorithms for robots to maximize the human-robot team efficiency. And in this area, we are working on decision-making systems for advanced manufacturing, language-enabled agents that are able to converse naturally in natural language with humans to retrieve information from people during task execution, and the robots that are capable to teach people new tasks in a natural, transparent, and task-efficient way. I believe that both these areas, both the high-level algorithmic HRI and the low-level physical HRI problem are important. Both are scientifically interesting and both have clear opportunities ahead in terms of impact on society. And in terms of impact, my vision is to achieve what I like to call elbow-to-elbow human-robot collaboration. So robots that engage in close and extended interaction with people. And I believe that these technologies are going to have an impact on a variety of different fields. I'm highlighting some of them here. Obviously, the main focus is advanced manufacturing, but I would like to point out that this is not an exclusive goal of our research. Basically, everywhere you need the flexibility of that automation, everywhere you need reproposability, so everywhere you need to repropose your robots to new tasks, everywhere you need the robots that work, that are co-located in space and time with the people and work in a close proximity with people. This is what our research is about. And most importantly, again, I've just started, but we are looking at also new application domains. So if you're thinking of some robotics application in your field of research, or some robotics in your industry, or adding some more robots in your industry, we should definitely have a chat. So luckily for us, this is the last talk before the break. So I look forward to chatting with you in a little bit. Thanks.